Hi everybody, my name is Yalda and I'm going to be one of your sport
Hey guys, we had a quick question about partial fractions. So the question was asked like something like this, and it basically had nothing to do with actually integrating, but so much with integrating as it did with actually breaking this guy into fractions. So let's worry about that part. So before I do any integration, the question is really, how do you decompose this into two fractions? Okay? But the first thing I want to check always is just make sure, look at the highest power here. So x times x squared is x cubed. Make sure that's bigger than the guy on top. So here clearly x squared times x is x cubed is bigger than x squared, so we're good to go. Okay, and the first thing is, without the integration, I want to take this guy and break him into pieces. So the natural thing to do is look at these factors, right, and set them up to be different denominators. Okay, the other thing you want to check is, can you break these guys down? This guy's linear, right? It's just x, so you can't break him down. This guy's an x squared, maybe you could break him down. So here's where it's important to remember. If you have something like this, difference of two squares, you really can break them down into x plus 2 times x minus 2. Okay? But if you have something like we have now, where you have any guy where it's x squared plus a constant like this, there's no way you can break this guy down. Okay? And we'll talk. And I may get a chance to talk about that later, but basically for the moment, if you trust me, you cannot break guys like this down. So in this setup, you've got x squared, right? And then some positive guys, so you can't break this guy down. Okay, so do you guys remember the format? So the format is, if I have a linear factor here, it's got to be something like a, right? If I have a squared term here that you can't break down, then you've got to put constants in for the x term and the non-x. You kind of think of it this way: if you have an x squared term, what's weaker than that? An x term and maybe a constant term. Okay? For an x term down here, the only power lower than x to the 1 is literally x to 0, so you can only have a constant term. It's kind of retarded, but the first thing we do is we break this guy into pieces. We look at this denominator and this denominator, but to figure out these coefficients, it's kind of retarded. We just broke them apart, we put them right back together. Okay, so putting them back together, you need a common denominator. Obviously, the common denominator here would be 2x minus 1 times 4x squared plus 2. Right? Getting right back to where we started. But if you had these numerators, multiply by 4x squared plus 2 on bottom here, you've got to do it up top here. So then you get a times 4x squared plus 2. Okay? And then on this side, in order to make this guy look like this on bottom, I have to multiply this guy by 2x minus 1. So if I multiply the bottom by 2x minus 1, I have to multiply the top by 2x minus 1. So again, I would get bx plus c times 2x minus 1. Okay. So let me clean this away. So here was our goal. We wanted to get somebody that looked like this. Okay, I have this set up. And right now we have this chunk. Okay. And shouldn't have erased it, but our original setup, remember, our original problem looked like this. 4x squared minus 2x plus 9 over . Okay, so this is what we started with, this is what we want to end up with, and this is how we're translating it so far. Okay, so no big deal. But look at these two guys. You know, remember, we're supposed to be the same guy. So that means if the bottoms are the same, right, and they're equal, then the tops must be the same. Okay, so the traditional way would be this top right here. Let's go ahead and write. So let's write this term, 4x squared minus 2x plus 9, that top over there, equal to this one, which is a times 4x squared plus 2 plus bx plus c times 2x minus 1. This problem is a pain in the butt. So I'm actually going to show you two ways to do it. One is probably the way you've seen in class. So the way you've seen in class is pretty traditional, I'm guessing. Of course, I don't know for sure. And then the second way, you might have already seen it, but I'm just going to reemphasize it, is a shortcut. So here's the idea. So if I'm looking at, let's write this out. First, let's multiply this out the brute force way. So this is 4ax squared plus 2a plus, and let's FOIL this guy out. If we FOIL them out term by term, it's 2bx squared plus 2cx minus bx minus c. Okay, just nothing big, just FOILing that out, right? Then I want to collect terms. So if I collect terms, let's gather all the x squareds together, right? So there's 4a apples and 2b apples. So that should be 4a plus 2b apples, right? Now let's collect the x terms. So over here, right? So it looks like 2cx minus bx, but that's going to be the same as 2c minus b times x, right? So now let's collect those constant terms. So it's going to be 2a and minus c. Okay, so all we did, sorry, I kind of crunched that there. All we do is collect all the terms piece by piece. Okay, now I've got the right side. Let's look at the left side. The left side's still the same. 4x squared minus 2x plus 9. So if these guys are literally the same all the time, that means for the x squared, his coefficient, the number in front, has got to be the same on the right side and the left side. So the coefficient for x squared here is 4. Therefore, you know 4a plus 2b, what it looks like on the right, is the same as the left. So then we get this set up. Okay, so let's try it again. But not only with the x squared, let's do it with the x's. So on the right, the x's have to be 2c minus b, right, in front of x. On the left, in front of x, you have negative 2. So gotta have these guys be equal. Okay, and now for the final term. These guys represent your constant term. So we've got to have 2a minus c equal to the constant term here, the guy without the variable. So that's got to be 9. So now that I've got our 3 equations set up, let me clear some room so this isn't going to get too cumbersome. Let me take this away. And if you guys agree in this painful version of it, I have to combine these equations. I have to try to get rid of variables and fix this up. That's pretty much the only way I can do it right now. Okay? I'm going to try and make life a little bit easier and divide everything by 2 over here. Okay? And then if we want these guys to die out, let me rewrite this guy. So this guy is 2a plus b is equal to 2. That's this equation here, so I'm going to take him away. Okay? And then I think a nice one to combine is this guy, just because the b's are going to cancel out. So let's bring that over here. So that's 2c minus b is equal to minus 2. Okay, so this should be pretty, right? Just brought this equation over here, we're just going to add them together. Then the b's will kill each other, right? And then we get 2a plus 2c is equal to 0. Okay, that's very nice. And then if you want, you can divide everything by 2. 1, 1, and 0 is still 0. So now I get a plus c is equal to 0. Okay, so this guy's left over, this guy's left over, so let's go ahead and put them together. Okay, again, at this point you could substitute. I think it's easy for me to go ahead and write these up. So I have a plus c is equal to 0, and then 2a minus c is equal to 9, right? We'll add them again. Again, this is going to cancel out. So we get 9 is equal to 3a. Now I can finally solve something, right? So now I can solve, divide both sides by 3, and get a is equal to 3, right? Now just plug back in any equation that makes sense. But if a is equal to 3, and a plus c is equal to 0, you know that c has to be negative 3. Okay, almost done with this. Then go back one more step to any other equation. In fact, why don't we do this one up here? Sorry I erased them. Let me clean this up. Let me backtrack to this equation. So now you have 2a, but a is 3, plus b is equal to 2. So 6 plus b is equal to 2. So b has got to be negative 4. Okay? Okay. So now I have a, b, and c. We can plug back in and figure out what these guys are. Okay? But before we do anything else, let me catalog what we've got. And I think we have, and I'll put it up here. So I think we have a equal to 3, c equal to negative 3, and b equal to negative 4. Okay. Now I'm going to try this whole problem all over again, or this portion of the problem, and I'm going to try a cheap shortcut. So remember way back in the beginning, I started with this side of the problem. I erased the left. I'll put that back on there. The left side looked like this. Okay. So we're going to do this one more time. We're going to try it the cheap way. Okay? And the cheap way is, this equation is true for any value of x. Okay? Even for the ones that make the bottom 0. Okay? So there's a theorem that'll show you that it's true, but you don't have to deal with that theorem if you just believe me for the moment. These equations should be true for any x, so you can plug in any value of x you want. So why not pick the cheapest values? And the cheapest values are the ones that are going to make things go to 0. But if you square anything, you're not going to get this guy to be 0. You can put a number in here, but I'd be messing with variables. That looks difficult. So I think I'm going to start with this. Okay? Remember, what you're allowed to plug in for here are your x values. So what I'm going to do is, I'm going to pick a value of x that would make this 0. So you guys agree, if you picked x equal to 1/2, this term here would be 0. Because 2 times a half is 1, 1 minus 1 is 0. So this whole term would die, right? Fill in what's left. Then I get a times 4 times 1/2 squared plus 2 is equal to 4 times 1/2 squared minus 2 times 1/2 plus 9. Finish this equation, but 1/2 squared is 1/4. 4 times 1/4 is just 1. So 1 plus 2, and we get this. Right. On the left side, 1/2 squared is 1/4. 1/4 times 4 is again 1. 1/2 times 2 is again 1, or negative 1, right? And here's just 9 hanging out. So now I've gone down to this equation, but then these guys cancel out, and you literally get 9 is equal to a3, or 3a, same thing. So a is equal to 3. I think that was much faster. Okay? So now we have, let's count on our new results. A is equal to 3. Let's try to get the rest. Okay? So, we're not quite done yet though, because we need all the rest of the letters using this cheat method. If using the cheat method, we know that we can pick x equal to 1/2, and that got us the results we have so far. So we know that a is equal to 3. Why don't I just plug that in? To go back to the original equation, if a is equal to 3, then you get 3 times 4x squared plus 2 plus bx plus c. Remember, going back to the original equation now, 2x minus 1, just plugging in for what I know about a, is now 4x squared minus 2x plus 9. Okay, but this is easy. This comes out to be 12x squared plus 6, plus, I'm not even going to write this out yet, bx plus c, 2x minus 1 on the right. On the left, we're going to get 4x squared minus 2x plus 9. Okay. Why not collect terms to make things pretty? Does everybody agree? If I subtract 12x squared from here, it goes to 0. If I subtract 12x squared from here, I'm going to get negative 8x squared. You guys agree with that? And then I'm going to subtract 6 from the right. This will be 0. Subtract 6 from over here. That will make this 3. Okay, so now I have this equation and this one. Okay. Again, you could do this in a more complicated way, but be as cheap as humanly possible. All I want, for example, what if I wanted the x squared term? The only way, even without folding this out completely, you're going to get x squared, is to have this x multiply with that x. So you can actually do that term right away. That would be 2bx squared. Right? And I can do that comparison right away. Look at this x guy. The coefficient in front of him is 2b. Look at this guy, this x squared guy. Sorry, x squared, 2b in front. Over here, x squared, negative 8 in front. So you know, negative 8 must be equal to 2b. Same reasoning as before. So b must be negative 4. So now we have this. Okay. And let's finish it. What about c? There's a cheap way to do that as well. So you could always fold this out, and that would totally work. But again, only this times this will give me the x squared part. Only c times negative 1 will get you the constant term, which is negative c, right? Any other terms will have an x involved. So really, I'm going to have negative c, and I compare it to the constant term here, which is 3. So the next equation I get is 3 equal to negative c, so c is negative 3. Okay? If that bugged you, you could have just FOILed this out and done the same thing. But either way, let's FOIL this out and see. So then when we get this guy and this, right, plus this term, so bx times negative 1, so negative bx, right, times, or plus, sorry, c times 2x, so positive 2cx, and then the final term would be c times negative 1, or negative c. Okay, so we just FOILed this out on the right. On the left, we have this, right? And then comparing the two, we did the same game. X squared must line up with x squared, so 2b must line up with negative 8. That's what we did before. And also, I didn't bother to compute this because even though these guys would line up with negative 2 over here, we don't need that. Because all we're trying to do is solve for b and c, right? We already have one equation that says this, so we can solve for b, right? And we also have this, the constant, well, we also have that 3 must equal the constant term over here. So 3 and c are actually, negative c is 3, right? And we can obviously solve for this. So that would do it. Okay? That's why then for a shortcut round, what I did was I equated without actually FOILing it out. But if you had FOILed it out, you would have gotten the same results. So hopefully that helps.
If you have any questions, you can email us at sportworldprep@gmail.com.